Here I have my expanded function ALU. So in addition to the general functions that I had before, it also has shift left, which is basically times 2, shift right, basically divided by 2, 1's complement and 2's complement. Now these functions are going to be applied to the first input, A. So if we have 0, 0, 0 for shift left, if we take 1, we can see that 1, which should be here, is just shifted 1 to the left, and it's multiplied by 2 to produce 2. 2 is the same to 4, and 3 to 6. Now if we take shift right, 1 is shifted right off to the right, so it just gives us 0. 2 shifted to the right, and we get divided by 2, so it's just 1. 3, that 1 is still shifted off, so it gives us 1. 4 divided by 2. Now for the 1's complement, 2's complement, we take 1's complement, it's basically just an inverse. And then 2's complement, the inverse, plus 1. So this is the internal circuitry for my expanded ALU. We have all the normal functions up here. And then to integrate the secondary functions, I basically just used a bunch of different muxes in order to tournament style knock out each output that we get until we get our desired output. So starting down here, we have our shifting functions, shift left and shift right, and a mux decides between them with S0. And similarly, we have 2's complement and 1's complement here, going through a mux also decided by S0. So both those go into a mux, whichever won those 2 rounds. And then of those 2, one is decided by S1 to go on to the next round. And we get our function from this top half, as well as our added on to functions. And S2 decides in between one of those. It gives us our final output. It's useful to have a multifunctional kind of calculator like this in the middle of a microprocessor, because whenever data comes in that we need to do something with, send somewhere, no matter what that data might represent, it's still going to come in as binary numbers. And as numbers, in order to manipulate it or control it somehow, we need to use math. So no matter what those numbers might represent, they might be actual numbers that we just want to add or subtract together, or it might be anything else that we want to compare to itself, or compare to other things, or send somewhere or manipulate somehow. We need math in order to manipulate the binary numbers to change what they represent.